Hello, welcome to Learn a New Work, an NMF HMM speech enhancement method based on KL divergence. I'm Young, and this work was completed in Audio Analyze Lab, Aalborg University, and the CAP2E. So, firstly, let's see the roadmap of this presentation. Firstly, I will give the background. After that, the motivation will be illustrated. The details of proposed algorithm will be indicated in part 3. After that, I will show our experimental results. Finally, I will draw the conclusions. So first, let's learn about the background. Nowadays, we are always surrounded by various noise, such as some bubble noise, factory noise, and so on. So the speech enhancement techniques were developed. The aim of speech enhancement is to remove the background noise from the noisy environment and improve the quality and intelligibility of noisy speech. Currently, the speech enhancement has achieved a wide range of applications, such as hearing aids, mobile communication, robot speech recognition, teleconferencing, and speech coding. So during the past decades, and the speech enhancement has attracted many researchers. So a wide range of speech enhancement algorithms were proposed. In general, the speech enhancement method can be divided into the supervised method and the unsupervised method. For the unsupervised method, it includes some signal space algorithm, MME estimator, and some Wiener filtering-based method. For the supervised method, there are some codebook-based method, autoregressive hidden microphone model, and some DN-based method. It also includes some NMF-based method. And in this work, we propose a novel NMF-based supervised speech enhancement algorithm. So the motivation of this research includes the two parts. At first, the traditional NMF-based speech enhancement method do not consider the temporary information of clean speech and the noise. So in this work, we want to use the temporary information for NMF. Additionally, we want to achieve the efficient online speech enhancement using the NMF and the HMM. The highlight of this project includes that we use the sum of portion distribution as the state condition likelihood function for HM rather than the general general Gaussian model, because the portion distribution can lead to KL divergence measure, and its parameter update rule is identical to the MU rule, and this can cause the efficient online speech enhancement. Additionally, in the online speech enhancement stage, we proposed a novel NMF-based MMSE estimator for online speech enhancement. So in the next part, I will illustrate the details of our algorithm. In this work, we consider to achieve speech enhancement in the active noisy environment. So the noisy signal model can be written as the equation 1, and equation 2 is it STFT format. And in general, for the NF analyze, the magnitude of a signal V can be represented as the W multiples the H. And the equation 3 shows this process. And where the W denotes the basis metric and the H denotes active metric. Based on KL divergence, the W and H can be estimated using the MU algorithm, and which can be written as the equation 4 and equation 5. After we estimate the W and the H, we can reconstruct the signal V. And additionally, in previous research, it has been proven that the NMF with KL divergence can be also motivated from the following probability model by using the portion distribution, where the K is the number of basis metric and CFN is latent variable of CK for portion distribution. And by using the equation 6 and equation 7 and combine the EM algorithm, the update of parameter H and W is identical to the MU update rule 4 and 5, which applies the KL divergence. And next, I will indicate the HMM-based signal model with KL divergence. Based on the equation 6, and we propose model the clean speech Sn using the HMM. So in our proposed method, the clean speech Sn can be modeled as the equation 10, where Xn is the hidden state. Additionally, the model also includes the initial state probability pi bar and the transition probability metric A bar. And the noise, and there is a similar model for noise. So finally, the noisy speech model can be represented as the equation 11. From this equation, we can find that in our method, there are more than one basis and active metric because we consider the temporary information. And in the offline training stage, the aim is find the parameter set to maximize the likelihood function, which is based on the KHMM and EM algorithm. And the complete state likelihood can be written as the equation 12. So by applying the EM algorithm, the model parameter update can be represented from the equation 13 to 16. We can find that in equation 15 and 16, the update rule is similar to the previous update, but we include the lambda, which is calculated by using the forward and backward algorithm in HMM. For the update of pi bar and A bar, it is the same as the traditional HM model. And in our model, there are more than one basis and active metrics. And in the online speech enhancement stage, we propose to combine the NMF and HMM model with MMD estimator for online speech enhancement. So finally, the enhanced signal can be written as the equation 18. And combined with the previous method, there is the weight omega in our proposed MMSE based online speech enhancement estimate. The omega can be calculated by using the forward algorithm and the posterior probability, and the PN it can be written as the equation 21. By applying those equations, we are able to apply the enhanced speech by using equation 18. And so in that part, I will show the experimental results. In this study, we use the TIMI database to train our clean speech model. And we use the noise CT192 to train the noise model. And we just use the bubble F15 factory and the white noise to train our noise model. During the test stage, we using the TIMI test set and random choosing 200 utterance to conduct the speech enhancement. And the 4 types of noise are added at 3 different SNR levels. And this is the details of some settings. Each includes the sampling rate, frame length, frame shift, and the size of STFT. So, and this is the experimental result. In our experiments, there are 2 stages. At first, we will investigate effect of the number of clean state for the NMF model. In this experiment, the vector number of clean speech and noise is fixed. Additionally, the state of noise is also fixed. And from this figure, we can find that our proposed method can achieve higher pass score than the traditional NMF because our method includes the more bases and active metrics. And additionally, we consider the temporary information using the HMM. And in the next stage in our experiments, the proposed algorithm is expected to be tested under more types of noise, and it includes the more types of noise. And we use some reference methods. It includes the TMF, OMSA, SL, NMF, and the log MSE. And the average story test for all types noise and SNR is showing this figure. We can find that our proposed method can outperform than some traditional method, and it can also outperform the NMF-based supervised method. And this figure shows the spectral comparisons. By comparing with other methods, in our method can reserve the better harmonic structure, which can be shown in the black area. And also our method can also remove the more noise, and it is in this blue area. And finally, I will give the conclusions of this research. In this research, we propose an NMF HM-based speech enhancement algorithm, which applies the sum of portion distribution, which leads to the KL divergence. And this is an efficient strategy to train our model and achieve the online speech enhancement. Additionally, we propose a novel NMF HMM-based MMST estimator to conduct the online speech enhancement. By experiments, we found that our method can achieve the higher pass and story score than the reference method. And our method can be also have the better performance. Thanks. And that part is the Q&A questions. Thank you.